This is basically intended as a follow-up to the first tutorial, which I'll link in the description. It's to explore some more advanced features of cljfx and see what we can do in terms of working with servers and APIs and stuff. So let's get started with a new project. Okay, that's our project set up with line, so let's get into some coding. First of all, we're going to add the dependencies, and I'll just quickly fill out some of the code based on what we did in the previous tutorial. Okay, that's all set up, so just to go through it, it's pretty basic. We have our state, and we're going to take an API key in for our interaction with the LLM API. We're going to implement a router, so we can move through the UI and see different scenes. Simple context for state. This is our main view, our first view, and we'll kind of see what it looks like, but it's basically a text box for the API key and a button. Then event handling, we've made this more generic here. So instead of hard coding specific interactions, we just do a generic assoc in, which takes a key, and the event, which comes from here. So because the onText change is a cljfx event, you get this fx event passed through automatically. Then we just swap the context using assoc in. Same for the stuff for the event handlers, same stuff for the renderer. We're going to use the style sheet from the start this time and just call run at top level. So by default, we show the UI. So let's hook up to the REPL. Oops, I had a mistake in my project file. Let's try again. So if we type in here, just check. Yep, our state's updating as expected, so that's good. So basically, how we want this to work is sort of like almost like a login. So in order to interact with the LLM APIs, you need to put in your API key. We don't want to maintain our own server that handles LLM interactions. We just want to do it directly from the client. So the user puts their own API key in. The way the LLM API works is if we look at the documentation, close this for now. Look at models, list. So in the shell, to list all the available models, you still have to provide your own key. So because this is sort of like just a simple get endpoint that doesn't cost anything, doesn't require any state or interaction from the user, we can use this to basically verify if the key is correct. In fact, they might have their own endpoint for checking if it's correct, but this is just how I've been doing it. So we're going to make a request to the list endpoint, and if that returns okay, then we know we're good to continue. So we'll sort of bypass this screen, move on to the next one where we can show some actual interaction with the app. So to do this, we need to get a couple more libraries, one for HTTP interaction and one for JSON. Right, so now we've got those new deps. Let's import them and use them somehow. Let's add a few more things to the state. So we're basically going to track if we're connected. So basically if the API call succeeds, whether we're loading, so if we're currently doing the request, and an error if it fails. We're going to add a connection message to the main view to show the user what state we're currently in. Now we just need to implement this connection message function. Notice how it's a subctx, not a subval. It's subscribing to a function rather than a value, so we can basically do more things in there. So because we're using subctx, we can do multiple subvals within. So these are the cases we want to cover. The most important one is if we've tried to connect and failed, then we show the failure, the error message. Otherwise, we show loading while it's submitting. Because we're going to basically root on connection, this probably won't get shown, but just as a fallback. In fact, it could just be omitted completely, and then we wouldn't even need this flag either. And then otherwise, this is the default message. So let's just compile everything. My mistake, I imported this wrong. Oh, and this. There we go. So now we have our message, but it doesn't do anything yet. So let's implement the behavior. And before we do that, you'll also note that we're actually using the style classes now. So these come from cljfx. You can see how this is blue because it uses the accent style provided from here, cljfx theme styles. So this is how you style components from a style sheet, basically. Okay, so to make HTTP requests, we're going to treat them as an effect, similar to how we had the file system effect in the video before. So we're going to basically implement an effect that takes information about making an HTTP request and then puts it through the Clojure HTTP library. And you'll see that we're going to use dispatch here as well, which we didn't use before, which is a way of chaining events. So here we're modifying the map that the HTTP client is going to get. We're going to tell it to be async, which I think makes it run as a future, as JSON, so we specify the response format. And then we also remove these from our inputs because these are maps to do with our system of handling the events rather than what Clojure HTTP expects. For the HTTP client, this is the success function, this is the failure function. If it succeeds, we will dispatch a new event and add the response. So this on response is going to denote the event that gets fired if we have a successful request, and we tack on the response in there so that we don't have to manually add it elsewhere. And for the exception, we do the same thing. This will be the event that gets handled on exception, and we add the exception in there, and do the same for the general error case. Now we have to hook these up to the event handler. So if you remember before, how we add effects is we put them in the wrap effects. So we've added our HTTP effect, which says if any event handler returns something with HTTP in the map, then we pass it to this HTTP effect. And since we're using dispatch, we also need to use the cljfx dispatch handler as well. So basically this is what this is doing. This gets returned and then looks for this and it passes through like that. So we're firing our event here, test connection. We actually need to implement the handler for it. So we're going to have 3 handlers for this initial case. First one is the test connection, which launches the HTTP request and goes to the effect. And then the other 2 are the on response and the on exception handlers to handle both cases of what happens after this returns. So let's add those. So our test connection event returns 2 effects. The context effect, where we just say that we started loading because we're about to make the request, and the HTTP effect. So these are 2 parameters that Clojure HTTP will expect. So we're saying it's a GET request, and we're making a request to this URL, which we got from the documentation from the Google API. I'm just using the Google LLM because it's either really cheap or effectively free, and it's easier to just focus on one, and also to not have to pull in an LLM library dependency. We just want to showcase some simple REST API interaction. So now we'll do the other 2 events that we need to add, verify connection and API failure. I'll do the failure one first because it won't lead on to anywhere, and then we'll do the verify connection. The HTTP client gives us back a map of the response. We get the body out of that, pass it to a string because it returns JSON. This true says give us keywords back in the map instead of strings when you pass the JSON. And then based on the structure of the API, this error message will give us a message. Another thing just to clarify is that this HTTP effect, these 2 cases here are what add the exception to the event map, which we get out of here. So these 2 are connected and that's how it hooks up. And we basically we say we stop loading and we add the error, which can be displayed by this connection message here. Now to implement the verify connection event. So again, response comes from down here in the effect. But we also have to handle an extra failure case. So the endpoint can return like a 400 or a 500 status code. So we check the status, and in the happy path, we update the context, and otherwise we dispatch by returning a dispatch effect. I'm going to say that we want to fire an API failure and just pass the response to this handler here. We just need to implement this check is connected function as well. So basically we look through the HTTP response in the 200 case. It gives us this list of models and we just look in there for one that we know it should exist. Obviously this will get outdated at some point, probably when they remove or deprecate this. But anyway, sort of like a form of validation just to make sure that even in the 200 case, it's working as we expect it to work. So now if we test this, if I put in a bad key, there you go, it says please pass a valid API key. Now if I put in a correct API key, there we go, we're connected as expected. Now, to make this a little bit more convenient for the user, we can add an FS effect to save the API key to the file system, so that when you open the program again, it will remember your API key and you don't have to type it in every time. So if you see, if I close that and then recompile, it's gone. So what we want to do is read from the file system our API key, and it just makes it more convenient for the user. Let's do that quick. We'll implement a function to read the API key from the file system. So basically, look for the API key file in a known location, so it's just in the same directory as we're working. File exists, we try and read it. If anything fails, we return a string. If it doesn't exist, we return a string, and that should give us our API key if we have one. And now we can update the initial state to use that function. This will impact loading time, because obviously this is a def, it's running at top level. You don't really want to put too much in here because it will slow down the startup, and I think that's particularly more important in mobile apps, but in this case I think it's fine. We're just doing a quick file read, but say you were processing files or making a web request or something, then that's probably something you want to handle with a lifecycle. So let's add this. Now in the connection message, we can also load the API key from the context and change the message. So because our default case is enter your API key, the user will already have one, so we should change it to say press the button to connect. Okay, so we're just going to display this message if the user's put an API key in. This should also change if you don't have one loaded, but you type in there, that will re-render. So just recompile. Yeah, so now it says press enter to start your session. There you go. Now we need to add the FS effect to handle writing the file. We'll keep it really simple and just give it a path and contents and write the file directly. We aren't chaining any events from this. It's just kind of a fire and forget, so we don't have to include the dispatch. Now we have to add the effect handler down here too. The last thing to do is actually write the API key file. So we only want to do that when the connection is verified, so that we know we're always saving a correct API key. So we want to do that in the first branch of the if here. So this is just saying subscribe to the API key value and pass it as the content, because all we want in the file is just the API key itself, and the path is just the same path that matches up here. In fact, let's just define this one place. So now let's test this. If I put in an invalid API key, we should see no key file. But if I input the correct one, our API key file is here. Now if we recompile and bring the program back as if we had closed and opened it, if it was a production app, you see that it's loaded the API key and it's correct. It's the same one we used before, and I didn't have to type anything in, which is nice. Right, so how do we make this more useful? How do we add the routing so that we can get off this first screen? Well, there's probably nicer ways to do this. I know that Clojure has a few routing libraries, but I'm just going to do it with a simple case. So what we need to do is we need to refactor this a little bit. So we're going to create a connect view and a main view. So the connect view is the initial screen where we enter the API key, and the main view is going to be our main interaction view. So let's refactor this a bit. Okay, so we have our two new components, the connect view and the main view. We're not rendering anything in the root, so what we want to do is put a router here. It will look at the state and show the correct component, the correct corresponding component. So here you can see before, in our state, we have this root key, and these are basically our URLs. So we're going to start with first, and we'll add another one like view main or something for the main view. So let's add a router component, and in the root, we just render the router. So as you can see, we subscribe to the router key in the state, which is here, and show different components based on each one. The only other thing to do now is hook the navigation up. So basically in verified connection, if we're correct and it connects correctly, we just want to change the view. So we'll add, so basically, yeah, set the view to main if we connect correctly. So now if we test this, we're now on the main view. So the next step is going to be a bit more bulky, and I'll explain some of the general workflow of the app. So what we're going to do is let the user enter a Wikipedia URL in here, and we're going to use the LLM to create a quiz from it. This is basically like a RAG light kind of thing, where we're passing in a limited amount of source material that we know is going to be good, and just ask the LLM to extract information from that small amount of source material to create a quiz from like a known kind of source. So what we're going to do is take the URL that the user gives us, load the wiki text article, so we don't have to deal with worrying about kind of passing HTML, even though we're just going to let the LLM pass it anyway. It should know how to handle wiki text and extract information, but the beauty of it is we don't have to pass that information. Even though we could, we're going to the LLM anyway, so we might as well let it deal with that as well, transparently. So we request the wiki text, extract it, create a prompt, and pass the prompt and the wiki text to the LLM API. And then that's going to give us back a quiz with 5 questions, multiple choice questions, which we can then show in our UI. So really just spend a bit of time implementing that. We're going to refactor the main view to have some local state, like we covered in the tutorial before. We don't really care about this Wikipedia URL in top level state. It won't be used anywhere else, so it's a good candidate for local state. And refactor the main view to handle that. Here we hook our URL field up to the local state and pull the URL out of it from here. And then on text change, when we type in that URL field, it will update the local state. Here we add an event call to our, when we click the button. So we're going to make a new event, fetch wiki, pass the URL from the local state here. The other thing is we're going to reuse the loading from the top level state. So disable the button when we're loading so that the user can't spam the button while we're making requests to the LLM or something. And here we'll just notify the user if we're loading the quiz or if we're just in the default state. Okay, so that's pretty much our UI changes hooked up. So now we need to implement this fetch wiki event. Okay, so because we want the user to pass in just a normal Wikipedia page URL, we need to convert that URL to the wiki text equivalent of that page. So we'll just write this function URL to wiki text API, which just transforms the URL so that we can request the wiki text version. So we have this little function which creates a Java URL, gets the path out, and we do this transformation and then rebuild the URL here. So we can test this in a comment. So if we open this URL, you can see we get the wiki text page. But this is plain text. So the other thing we need to do is down here, you'll see that we always expect a JSON response, but this won't work. So we need to also pass through to the HTTP effect what kind of response we want. So if we add an as syntax here, then we need to update the effect to handle this. So this is saying check the request ops. If it has an as, pull that out, otherwise default to JSON. So because the as exists here, it's going to use text in this case. The other thing is we need to remove as here. Okay, so we've set up the initial fetch with the HTTP. Now we need to add the chain events, so we need to implement getQuiz. This will work like the verify connection event where we have the same context and response that we want to get out of the parameters. So for now, we have the fetch wiki hooked up to the button, and this will chain off the HTTP effect. So we can just print the response here and see if it's doing anything. Compile this. And then if we use our URL here. This looks like a response. So in the get quiz, we basically want to do a similar thing to what we've done before, where we're going to make another HTTP request. This time we're going to be making a request to the generate content endpoint rather than models here, and pass a prompt to get a quiz response. So let's remove this and implement the function. So we're just going to pull the entire wiki text out of the body, like what we printed before. And the only thing we want this event to do is basically pass the data along in the process. So we're going to just take the response from the previous request, pass it to the next request, which is the LLM one. Okay, so same idea as before, really. We get the API key from the state. We're going to have a response and an exception event that gets dispatched, and we just pass URL and post. Wiki text comes from the body of the previous request, and we're going to implement this quiz request function to create the request that goes to the LLM API. This is one of those cases where using a dynamic language is nice, where you get these nice syntaxes for maps. We're going to use the response schema functionality of the API, which basically means you pass it a JSON spec and it will return its response according to that spec. We want to structure our quiz response from the LLM API in a way that's reliable to work with. So we're just going to use the JSON library to take a map and generate the request that the LLM API will expect. So according to the API, this is the actual kind of conversation that we have with the LLM. So this list will be a list of messages, but we only ever want to send one. So in this case, we'll just send the text as a function that gives us a prompt based on the wiki text. The rest of this request map is going to be to do with the generation config. So this is our schema that we want it to return. We basically say, give us an object with one key, questions, that's required. The question should be an array, and the items of the array should be objects. Each of these object items should have a text, string, correct answer string, and incorrect answers, which will specify in the prompt 2 options. So an array of length 2, both of which are strings, and all of these are required as well. If you use the Google AI Studio, they have a nice GUI builder for these structured output schemas. So if you enable this, go to here, and then their visual editor, we can do something similar like this. Questions, there's an array of objects. So this specifies an array. Each of the items should have text, that's a string. And then let's just do blah, list of strings. And then if we look at the code editor, it will give us this similar setup where we have object at the top level, questions, type array, and its item should be objects with text and blah, which, yeah, you can see how that works. Right, so we just need to implement quiz prompt to give us the actual prompt. So we have some kind of prompt which tells the LLM, denote the correct answer, give us some incorrect answers, where to put them in the JSON output, and then we just put the wiki text article in the end for it to process. So the only thing left to do is implement this show quiz event. So we'll just do that quick. So before we actually hook this up to the UI, we'll just print out the response and make sure it's doing the right thing. So what we have here is we take the response from the HTTP effect, pass the body as JSON, then we take that response and we extract the contents at this path, which is documented in the Google API documentation, which in fact we can see. We go to generating content. So it follows this kind of big object. What was the path we had again? Candidates, content parts, text. So we're looking here. Oh, this is the request. So in the response, click this and we get candidates, content, parts, text. So yeah, it's a big object, but Clojure's get-in functions makes it so easy to deal with. Obviously, this isn't the most resilient thing in the world, I'm pretty sure you can rely on this structure if the response is correct, but you'd want to add some error handling. Like I think they give you a response reason, which we're going to ignore, but it can fail, and so you should look at that really. Otherwise, this won't work. We made the request to the LLM. The body gives us back JSON. So we follow the path through that we saw in the API. The LLM API doesn't give us JSON here. It gives us text because this is just part of our LLM conversation. And it doesn't know about it. I mean, it's structured the output in a string, but it's put it in a string. So this is why we have to pass. We're basically passing what the LLM told us, despite the fact it happened to tell us in JSON format, but the API doesn't know about that at this point, so we repass it. So yeah, we're just printing this quiz content here. Okay, so to hook this up, I'm going to add some quiz state in the top level state. We're going to add a new route to our router. We're going to tell the event to route us there once we've got the API response. So here we're saying change the view to the quiz view, add the quiz data that we got from the API as the quiz, and say we're not loading anymore. Now the only other thing to do is implement the quiz component itself. So here we do a get in because if we look at the format, we're following kind of the general good principles of REST API design, where basically the top level should return an object so that it's resilient to change and maintenance. So we have to get the quiz, which we put directly in, and then the questions out of the quiz. Okay, so you'll have to forgive the format here. Basically, when I was writing this initially, I used a scroll pane and then a VBox and hacked the color in. I'll change that later on, but because I had some bugs that I didn't know how to work around that I eventually fixed. We're going to render all of the quiz questions, and to do that, we're going to loop over the questions from the state, and because for returns a lazy sequence, if you try and render a lazy sequence in cljfx, you get a crash. Something to do with how the internals work. We just basically force it to be a vec so it's consistent. So cljfx has keys similar to React, basically just a way to tell it what it's rendering. We're going to implement the quiz question. So here we're taking the actual values that the LLM gave us. So here you can see correct answers in there, incorrect answer. We're pulling these out of the object directly. We're going to shuffle the answers so that there's some variation in the UI each time the user wants to answer them, and then we're just going to render them. Use the vec trick again. So we flatten to combine the map here with the loop here. We're using fx key again in the loop. One note about key is it goes in the level of where you're rendering. So note how we're rendering a function component quiz question, but we don't put fx key in the quiz question component itself, we put it in the loop where it's rendered. And I think this is similar to React. Right, so we've got the quiz view hooked up to the router and it should be navigating, so let's see if this works. We'll pull that same URL as before. Don't need that. Okay, so it routes us to the quiz view. Now this doesn't do anything yet, but this is the general layout we want. So you can see how the LLM's given us 5 questions, each with 3 options, multiple choice, where it should have 1 correct answer and 2 incorrect answers. So that's looking good. Right, so as of now, we don't have any inputs. These do nothing. We can't leave this page, so we're going to want to implement something to do with that. Let's implement the question answering first. So to do that, we're going to track this in local state again. Let's add some local state here. So we're going to just track the inputs that the user makes. Now we need to hook up the local state to the quiz view. Here we're using the insets from JavaFX. So creating an instance of the insets class directly. And then this is another way of specifying padding in JavaFX. I think it goes top, right, bottom, left for padding. Okay, so there's a couple of things we need to do here still. Implement get score, implement this close quiz event, but I'll just give you a general rundown of the refactor. So we've added a top bar here to the quiz with a back button and then a score. This is going to track correct answers. Then we have a list of the questions. So we map indexed, which basically is like enumerate from Python, where you get an index and an element. We render the quiz question, and we just added a couple more properties in here. So we've got a callback for answering questions. We pass in which answer the user has chosen and whether the question's been answered. And we also have the key for stable rendering. I'll implement the close quiz event quick. So set the quiz back to nil when we leave the quiz and set the view to the main view. Now we can implement get score. So this basically ties into how we answer questions. So we maintain the index of each question. In our local state inputs, we associate each answer with its index. Then we add the answer the user chose into this input state. Then we pull the inputs out. We iterate over each one of them. We keep the index and the choice, which get added here, which isn't implemented yet. Then we pull the correct answer out of the question by getting the question from the list of questions based on its index, and then basically compare whether the user chose the correct answer. That's quite a convoluted explanation. If I just show you a demonstration of how it works, it might be more obvious. So this is basically mirroring the setup we'll have. So this inputs represents our local state for the quiz component with 2 questions answered. These are the questions which we will have pulled out from the context here. So we have 2 questions and we don't care about the rest of the state for this example. So we're just saying the first question has a correct answer A, second question has a correct answer X. The user input A for the first question, which is correct, and input Z for the second question, which is incorrect. So this should return 1. So if we run that, compile, run, there you go, so it gave us the correct score there. Now, because we made changes down here to how quiz question is rendered, we need to mirror those by refactoring the quiz question component here. Okay, so we've added the click action for the button. So this will run the callback with the answer the user selected. The other thing we want to do is add some styling to the buttons to display whether they're correct or not. So we'll just implement this answer button class. So basically this is saying we always want the button style. Then if this question has been answered, if the answer is the correct answer, we show it in green. Otherwise, if this answer was chosen by the user and it's not the correct answer, we show it in red. So let's see how this looks. So if I go through, this was a Hungarian composer. But you see, when I clicked, it's re-rendered. And because we are shuffling in the UI code here, every time this gets rendered, we reshuffle the answers. So we can fix that in a sec, but I'll just show you getting a question wrong as well. If I can answer one wrong, there you go. So when we answer a question wrong, we highlight the wrong answer, but we also highlight the correct answer, because this is unconditionally saying if it's been answered, highlight the correct answer. Okay, so let's fix this shuffle thing. We can remove answers here because we don't want to shuffle at this point. And what we'll do instead is we'll modify what we put into the quiz state so that we don't ever track incorrect answers. We just add correct answer and incorrect answers together and just have a list of all the answers. So that fixes that, but we also just need to shuffle quickly when we get the response back from the API. So what we're going to do is we're going to take the past quiz from the LLM and then shuffle everything just once and then add it to the state. So we just need to implement this shuffle answers function. So the reason we have to put this here is the questions are a vector. So we're just taking the vector out of the quiz content, mapping over it, and then returning that vector. So we need to put it back in the expected object format. So what we do here is for each question in the questions list, we remove incorrect answers and we add an answers key which uses the same shuffle behavior as before, pulling incorrect answers and correct answer out of the original question object. Now if you run this, now it doesn't shuffle when we click. That's interesting. Did that just happen to be correct? Let's run it again, just to check, because that's very suspicious. There we go, it was just a coincidence. Okay, so that's looking good now. Scores updating, we have this back functionality, so that's looking quite good. Okay, so you'll notice how we have this no quizzes here. It's good that we can request quizzes, but we also want to save them so that we can come back to them. Let's say we've gone and reread the article and actually learned some stuff. We can then go back and test ourselves on the same quiz to see our progression, and we don't have to make new requests to the API costing us money. So what we want to do is, in this kind of spirit of local first software, we want to save our data to our machine so that we actually own these quizzes. So what we're going to do is create a SQLite database on our file system where we can save the quizzes. So to do that, we will add some more dependencies. So I'm pretty sure this is the go-to thing for working with SQL in Clojure, and we also need the adapter for SQLite to run it. We're going to import those new libraries. We'll create a connection specification so that we can connect to the SQLite database. I'm also going to manually create the database. So I'm using DB browser for SQLite, which is a nice lightweight program for working with SQLite databases. So what we want to do is create a new database, call it store, which is the same as our specification. We're going to create a new table, questions. Question should have an ID, a name. The name is text and it should be not null. And we should also have questions. Questions are also text and not null. Questions are going to be a dump of the JSON string that we get from the API. SQLite does have the capacity to work with JSON, but we're not going to actually use it directly. We're just going to pull the string out and handle the serialization in our Clojure code. Okay, so we've created our questions table. Write the changes, and now we have in here our store. There we go. So we're going to implement a SQL effect to handle working with that database. We just pass it a query, which is going to be a vector, and the DB spec we created earlier. We'll add it to the effects. And now that should be ready to use. So what we want to do is, when we show the quiz, we know that what we have is correct, as in our responses come back, we should have a valid quiz. So at this point, it's the correct place to persist it to our disk, because we know it's good. So we have this parameterized query. It's very simple, just inserting into the quizzes database, quizzes table that we just created. We're going to use the same hard-coded string for now for the quiz name, and we're just going to regenerate a JSON string for the quiz content after the answers have been shuffled. Okay, now we need to do some UI refactoring to handle loading and then rendering them. So we'll make changes to the main view component. Okay, so we're adding the list of quizzes as local state as well to the main view. You could definitely make a case for this being added to the top level state, but because of the way the life cycles work, you can't dispatch events during life cycles, which means we have to imperatively update some state somewhere. So it's better to imperatively update local state than it is to do global state. And we don't want to load all the quizzes initially. We want to do it when the main view gets rendered, so that when we come back to it, if stuff's been added, it will refetch. Basically every time we come to that, not every time it's rendered, but every time it's created, we want to re-request the quizzes that we have. And also adding things like that to initial state is a slippery slope in terms of performance, if that makes sense. So we pull quizzes out of the local state, which we've just added. And here's where it's going to get kind of dicey because my source is incorrect again. We're going to use cljfx, but that's actually an incorrect thing to use in this case. But I'll add it anyway and explain it after. Okay, you'll have to excuse me here. Getting kind of hard to follow what I wrote originally. So what I'm going to do is basically address this issue here that I talked about before. This is probably really difficult to follow, and I'm sorry about that, but here goes nothing. Okay, so effectively we've refactored the router so that we look at the view and render different components based on the view. We also need this fx key because it doesn't know how to correctly re-render if you don't have the key. So without the key, if you have two components, which this will be obvious in a sec, but these are both using local state, and I think they both render a VBox at the top. So if you change the view, it's changing from a state with a VBox to a state with a VBox. And there's nothing to tell ClojureFX how they're different. You crash because it can't replace it properly. I'm not entirely sure why. I think it's to do with how ClojureFX is telling JavaFX to replace components. But anyway, it caused a lot of hassle, which is why it's so hard to follow now. But yeah, we basically have, and there's probably a nicer way to do this as well without the duplication, but we basically just attach a key to each route as well. So let's just implement these quick. Okay, so we've basically just moved the functionality that we had directly in the router into their own components. I kind of like this anyway. It gives us a cleaner code here, and it also kind of separates the ideas of each one having its own local state. But yeah, you see the quizzes change we just made is persisted there. We've changed this to an anchor pane instead of a scroll pane. Scroll pane was always the wrong choice there anyway, because we want to have these sort of, we want the header of the panel to be sticky to the top, basically. So I don't know if you noticed before, but when you had the quiz, if you scroll down on the quiz, you'd lose the score and the back button, whereas really you want to keep them there the whole time and just scroll the quiz questions themselves. It's a nicer UI basically. So using an anchor pane here is the right thing to do. I was using scroll pane before because I thought that, well, I wanted to scroll, but I thought that the replacement error was caused by not having key, was caused by something else. So I thought if I have like a consistent component at this level in the router, then it will re-render correctly. But that was actually, it was actually an issue further down the rendering hierarchy that was causing the problem. So it was a bit of a mess, and this also means that we now need to update the other components to have that scrolling behavior. So in the quiz view here, we need to add scroll pane here. So this has stayed the same, but we've just wrapped it in a scroll pane so we can scroll the questions, but here, the top bar with the score and stuff, that will stay stuck because it's outside of the scroll pane. Right, so before I interrupted myself, we'll go back to refactoring the main view. So what we need to do is the top bar with the URL input can stay the same, but we just want to change this bit so that if we have some quizzes loaded, we'll actually render a list of quizzes. And once again, we need to put a scroll pane in here because you don't want to scroll away from the URL bar, but if you have a long list of quizzes, you want to scroll through those. Okay, so I think we're done with the refactor. Basically what I changed is wrap it in an effect to load the quizzes from the database, and the effect takes a function and it will pass these args to it. We only care about updating quizzes in the local state, and so we render our description, and down here what we've changed is if there's no quizzes, we say there's no quizzes, and if there is quizzes, then we're going to implement a quiz list component. We just have to implement quiz list and load quizzes. So we'll do the quiz list first. Okay, so we're going to basically just list all the quizzes. These are the fields from the database. Because we're rendering a list, we want this key, and then we just show the quiz name and a button to view it. And we're going to need to implement this view quiz event. But first, let's implement the load quizzes function. Okay, so this is our effect function. The args passed to it are swap state, so you can see how that feeds in there. We have a future, which I'm not sure is strictly required, but my thinking was don't block the UI, so use a future. We just execute a select to get everything, all the quizzes. This option here, normally JDBC will give you qualified keys, so it will come out like quizzes, ID. These will be the keys in each row, quizzes, name, so on. But because of when we interacted with the LLM API before, we didn't have qualified keys, we just said ID name, we want to unqualify them. And then this is saying for each row that we've pulled out, we want to update the questions value to be the parsed JSON string. So if you remember, I said we would just splat the JSON string into the database. And on the other end, we need to parse it before using it. I suppose the other thing to note is here we're prop drilling by passing quizzes to the quiz list. So where we render quiz list here, this prop comes from local state. So that's how the quiz kind of state flows through the UI. Okay, now there's just one thing left to do, which is hook up the button here, view quiz. We need to hook this up with an event so that we will actually root on clicking this. Right, so main view renders based on this effect. Load quizzes swaps the local state by updating quizzes with the quizzes from the database. So here's where the quizzes come from in the main view. We pass the quizzes to the quiz list. The quiz list takes the quizzes, loops over them, and then destructures the values. So then for each row, each quiz we render, to the event we pass the questions which have been taken from the database after passing them. So it's kind of like an up and down. I mean, maybe it's just my explanation that's up and down, but well, you sort of render, then fetch, then re-render, and the quizzes are available then. So let's just quickly implement the event. When you click the button, the questions get passed through, so that's how we access them there. So here we're saying set the view to the quiz view, set the quiz to the questions we loaded from the database. So this comes from the row. We reconstruct this questions structure that the quiz view expects. We reshuffle the answers so that they're different each time the user sees them, but using the same idea. And then that should be hooked up. So if we compile this, if by some miracle I've made it through, we've got no quizzes yet. Get our list. We can see a very long error message. Ah, yes. Need to remove this because we're not in a VBox here anymore. We're in a scroll pane. That's unfortunate. Can we just recompile that? Nope. See, one thing about cljfx is sometimes if you crash a UI and then try and re-render, it will just keep it crashing. So you have to fully recompile. I'm not sure if there's a way around that, but it is kind of annoying. Anyway, let's try again. Okay, so here you can see our headers kind of stuck to the top, so we always see the score. These don't shuffle, but let's make a note of the order here. So German composer and violinist is at the top. This doesn't work because I named the table incorrectly. Let's rename this. My table quizzes. Okay, that should be saved. Re-render this. Now if we look in here, oh yeah, it's already updated. So here we can see our quiz has been put in. this is the output of the API. If we go back with horrible rendering, we can see our quiz list. And then if we click view, it will take us to that. So if we put some answers in, view again, they're reset because it's using local state for the answers. Okay. Anyway, that's the basic idea of saving stuff to the local SQL database. It would be nice if we didn't have a hard-coded name of the quiz and we actually could take it from the URL. So let's do something about that. So we take the URL, get the endpoint, and then replace the wiki-related parts so we get a relatively nice-looking string. We get the name when we are fetching the wiki, and then pass it through with the response. This is going to get quiz, so we look for get quiz, which should now take name as a parameter, and then we're going to pass it through to show quiz, which writes the SQL file. So in show quiz, we also take name, and then instead of just using new quiz, we write the name instead. Go through all this rigmarole again. There we go. Now we have a quiz with a better name. Let's just quickly improve the rendering of the quiz list as well, because it looks ugly. Okay, so we've just added some spacing. We've put separators between each quiz in the quiz list, and we've done this region hack, which spaces the button and the name apart. Oh, also, let's align these two. Wow, never seen that bug before. Okay, so now we have our behavior looking pretty much where we want it to be. Let's package this so that we can distribute it. So to do that, we need to go to the project, and we will add another JVM option here. What this does is when we run line build, it will prevent the JavaFX thread getting spun up. So basically when that happens, the build will hang. So the build will actually complete, but in the CLI, it will hang because there's like a thread that won't get cancelled. Well, not even cancelled. There's a thread that gets started that shouldn't be started, basically. In the code, we add platform, and we're going to tell it to quit. We also want to not automatically run. It's handy for dev. I mean, you could put this behind day flag probably, but for now, we'll just comment it out. When we distribute this and an end user is going to run it, we don't want to have them manually create a SQLite database. So we're also going to create one in the main function. So a pretty standard table definition, ID, name, and questions based on what we created before. I actually don't think we need these. And then after we've created the database, we just want to run it here. So that actually mounts the renderer in the main function when it gets distributed. We should also put these files in a more sensible place. We're going to just put them in the user directory. Okay, so these just the API key file and the database file are just going to be placed in the user home directory. There's one more thing for completeness, because I mentioned it before, but it isn't relevant to packaging, is that we shouldn't be using the effect here. We should be using on instance lifecycle, and then instead of passing then and args here, it takes a onCreated and just a callback like that. So this probably illustrates more clearly that we wouldn't want to update global state here. It's cleaner to update local state. Otherwise we'd have to like swap the atom and stuff. Right, so I think all of that should be ready to go. So now to build, we can clean, just in case. Create an Uber jar. Actually, there's one more thing we need to do. Actually, I don't know if this fixes it, but I saw it in example code, so I'm going to add it. We put in an injection to the Uber jar. Not too familiar with how this works, but on the end of the code, maybe it adds an exit. So the problem I was seeing was the app takes a long time to close. And I thought this fixed it, so I added it, but it actually doesn't. So if you open it and do nothing and close it, it's fast. But if you open it and do that initial connect, then it can take up to like 2 minutes to close the app, and I'm not sure how to fix that. So that would be interesting to know. Anyway, if we run jdeps, I'm not familiar with Java really. I found this command. So we get the dependencies for the jar, and it gives us this list. I actually need to run uberjar again because of that injection, but the deps won't change. Then we can run jlink to create an environment for it. I noticed that there's GraalVM native image here, but I don't see why that would be necessary, so I removed it and it still seemed to work. Anyway, so we're writing to target Java runtime. Now we can run jpackage and use that runtime. We run this. It pops that up, but it's not finished yet. Okay, that's finished. So now if we look here, we have a DMG file. So if we run this, this seems to be a problem. I'm not sure how to shrink the size, but it feels like 200 and something meg for this app is extremely huge. So don't know what to do about that. 200 meg for a small app seems pretty bad, but maybe I'll figure out. We can then go to run it. So if I look at my applications, open Quizzy, we enter the API key. No quizzes, let's get a quiz. Okay, it's still here. Then if we look in the home directory, we've got Quizzy API key and QuizzyDB. If we open the database in DB browser, it's created the schema correctly based on what we added down here. There we go, we've got a Caspian Girl quiz. So there you go, it's packaged. I didn't do anything specific for Mac with jpackage. So maybe if you run it on Windows, it will give you an exe. If you run it on Linux, it will give you a binary and just work. But yeah, we now have a distributable application with a DMG. So that's kind of cool. That pretty much covers what I wanted to do here. I hope you enjoyed and I hope you learned something, and definitely worth checking out cljfx.